Assalamu alaikum dear students. Yesterday we have discussed the logarithmic differentiation and to which functions we apply such type of differentiation. Now today we shall do some problems of exercise 5.5. Now first example, which is question number 4 of this exercise, is find a derivative of x raised power x minus 2 raised power sine of x. Now let y equals to x raised power x minus 2 raised power sine of x. Here this function, that is y, it is subtraction of two functions. One, x raised power x, which is a power function. Second one, a 2 raised power sine x, which is again power function. And let us suppose that this y equals to u minus v of x. That is, this y of x equals to u of x minus v of x, where this u of x is x raised power x and this v of x is 2 raised sine x. Now we have to find dy by dx. For this, now let us differentiate this first equation with respect to x. So dy by dx equals to du by dx minus dv by dx, where this u is x raised power x, means power function, and v equals to 2 raised power sine x, means again power function. So for this we have to find du by dx as well as dv by dx. Now here u of x is x raised power x. Now taking logs on both sides, which implies that log of u of x equals to log of x raised power x, or log of u of x equals to x log x, because log m raised power n is n log x. Now when we differentiate this, because we have to find du by dx, which implies that differentiation of log is 1 upon u of x into, then again differentiate this u of x, which is du by dx, because differentiation of u is du by dx with respect to x. Now here on RHS we have two functions. We have a function which is product of two functions. One is x, second one is log x. So using product rule of differentiation, which is first function into differentiation of second. Now differentiation of second is, that is, log of x is 1 upon x plus second function, that is log of x, into differentiation of first function. Now differentiation of x is 1, so which implies that 1 upon u of x into du by dx equals to 1 by cancelling x in numerator as well as in denominator plus a log of x, or du by dx equals to u of x into 1 plus log x. Here this u of x is x raised power x, which implies that du by dx is x raised power x into 1 plus log x. So this, in this way we find this du by dx. Also v of x is 2 raised sine of x. Now this is power function. For power function we use logarithmic differentiation, provided this power function is positive. So taking logs on both sides, in this equation we simply get log of v of x equals to log of 2 sine of x, or log of v of x is sine x into log 2. Now again differentiate with respect to x, which implies 1 upon v of x, because differentiation of log is 1 upon v of x into, now again differentiate this v, which is dv by dx. Now this log 2 is constant, so it comes out from this differential, and sine of x, differentiation of sine is cos, so we get a dv by dx equals to v of x by cross multiplication into log 2 into cos of x. Now here v of x is 2 raised sine of x, which implies that dv by dx is 2 raised sine x into log 2 into cos of x. But dy by dx is du by dx minus dv by dx, which implies that dy by dx is, now this du by dx is x raised power x into 1 plus log x, while as this dv by dx is 2 sine x into log 2 into cos x. So simply we get dy by dx equals to x raised to power x into 1 plus log x minus 2 raised sine x into log 2 into cos of x. Hence in this way we use here this logarithmic differentiation, where the given function is sum of two power or difference of two power function. Similarly, if we have a function which is sum of two functions, that is x raised x into cos of x raised to power x plus x into sine of x raised to power 1 upon x. Let y equals to this function, given function, which implies that y equals to, suppose, u plus v. Name it first, where u is this x into cos of x raised to power x, v of x is x into sine x raised to power 1 upon x. Now when we differentiate first, because we had to find or we had to obtain dy by dx, which implies that dy by dx is du by dx plus dv by dx, because differential of some functions equals to sum of the differential functions. That is why differentiation of u plus v is du by dx plus dv by dx. Now we have to find the du by dx as well as dv by dx. Now u of x is x cos x raised to power x, which is the power function. So taking logs, log of u of x is x log x cos x. Now this log of u of x is x. Now log, here we have x into cos x. So this means using log mn formula, we simply get log x plus log cos x, which implies that log of u of x is x log x plus x log cos x. Now when we differentiate this, it is simply 1 upon u into du by dx. Now differentiation of this is differentiation of x log x plus differentiation of x log cos x. Now here we have function which is product of two function, and this 2 is the function which is product of two functions. Here we have x and log x, here we have x log cos x. So when we differentiate by using the product root, it is simply first function, that is x, into differentiation of second. Differentiation of log is 1 upon x plus second function into differentiation of first, that is 1. Now here using the product rule in this, it is simply first function into differentiation of second. Now differentiation of log cos x is 1 upon x, then differentiate cos, which is minus sine. That is why I write here minus sine x upon cos x, plus second function, that is log cos x, into differentiation of first, that is 1. So simply by this multiplication and division, we simply get 1 upon u of x into du by dx equals to x cancels, it is 1. Log x into 1 is log x. Minus sine upon cos is minus tan, that is minus x tan x, and log cos x, which implies du by dx is u of x into 1 plus log x plus log cos x minus x tan x. U of x is here x cos x raised to power x 1. Now here log m plus log n is log mn, that is log x cos x minus x tan x. You can also simplify it by considering y in this 1 equals to log e to the base e, because log e to the base e is 1. So in place of 1 we write this log e, log x cos x minus x tan x. Now again using log m plus log n, we get log e into x cos x by considering n equals to x cos x. So we simply get du by dx is x cos x raised to x into log e into x into cos x minus x tan x. So this is the du by dx. Similarly, v of x is x sine x raised to power 1 upon x. Now power function, simply take logs, which is log v of x equals to 1 upon x into log x sine x. Now using log m n here, we simply get 1 upon x is log x plus log sine x. By multiplication, we simply get log x upon x plus log sine x upon x. Now when we differentiate this equation with respect to x, we simply get 1 upon v of x dv by dx. Now here we have this function which is the quotient of two functions. One in the numerator we have log x, in denominator we have x. Similarly here in numerator we have log sin x, in denominator we have x. So by using the quotient rule of differentiation, which is denominator square, in denominator we have to write denominator square, into in numerator we have to write numerator into differentiation of a denominator, that is 1 upon x, minus numerator into differentiation of denominator, that is here 1, plus, now again using this quotient rule we get this very term. Now by multiplication we simply get x cancels, it is 1 minus log x upon x square, plus here cos upon sin is cot, that is x cot x minus log sin x upon x square. By taking x square common, it is simply 1 minus log x plus x cot x minus log sin x, or 1 minus, we have two logs with negative sign, so take negative common, it is simply log x plus log sin x plus x cot x. Now using this log m here, log m plus log n, we simply get 1 minus log x sin x plus x cot x upon x square, which implies that dv by dx is v of x into 1 minus log x sin x plus x cot x upon x square. You can also use here log e equals to 1 and using log m minus log n formula. So simply we get dy by dx is dv by dx is x sin x raised power 1 upon x into 1 minus log x sin x plus x cot x upon x square. So this is the derivative of v function, that is v of x. Since dy by dx, because we have to find this dy by dx, and dy by dx equals to du by dx plus dv by dx, which implies that dy by dx is x cos x raised x into log e x cos x minus x tan x plus x sin x raised 1 upon x into 1 minus log x sin x plus x cot x upon x square. So this is the required derivative or for such function. Now find dy by dx if cos of x raised power y is cos of y raised power x. Here in LHS as well as in RHS we have this power function. So simply taking logs by considering cos x raised power y positive and cos y raised power x positive. Otherwise we cannot apply the logs, which implies that log cos x raised power y equals to log cos y raised power x. By using m raised power n, we simply get y log cos x and x log cos y. So differentiating it is, now in LHS we have a function y log cos x. This means it's the sum of two product of two functions, one y, second one is log. In RHS we have x log cos y. This means that it is the product of two functions, one is x, second one is log cos y. So using the product rule we simply get this very term, that is y dy by dx of log cos x plus log cos x into dy by dx equals to x d by dx of log cos y plus log cos y into dx by dx. Now differentiation of log cos x is 1 upon cos x into minus sin, that is this, whereas differentiation of dy by dx log cos x equals to, again differentiation of log cos y is minus sin y upon cos y into differentiation of dy by dx, because we have to, at the end we have to differentiate the angle, plus log cos y. It is simply minus y tan x plus dy by dx of log cos x minus x tan y dy by dx and log cos y. Now shifting these dy by dx terms in one side, we simply get dy by dx is log cos x plus x tan y dy by dx equals to y tan x plus log cos y. Now taking dy by dx common, it is dy by dx is log cos x plus x tan y equals to y tan x plus log cos y. Hence dy by dx is y tan x plus log cos x upon log cos x plus x tan y. So in this way, for such function where y is present, means these functions are the implicit functions. So we find this it is derivative by using the implicit derivative concept and by using the logarithmic differentiation concept. So in this way we almost completed this exercise 5.5. so inshallah in tomorrow's video lecture we shall consider the parametric differentiation. So this means we have to differentiate those functions which are parametric in nature. So thank you.